My name is Gary Nixon, and I work for a company called IES. So just a little introduction to who we are and where we're coming from, first of all. So we've been around for 21 years. We've been pioneering in a very particular place, that's building simulation. So if you know anything about building simulation, it's where architects and engineers at the design stage of a building's life will go in and use building simulation to go and help them to quantify the impact of different design decisions. So if they are going to put in some brise-soleil, if they're going to go in and change the systems out, how's that going to impact on my energy consumption, how's it going to impact on the occupancy comfort, and all those good things, and looking at it in a holistic way. So IES has been around for 21 years in this field of building simulation. We're very much so a company that's about people, and knowledge. So that's something that we treasure, and our company culture is what drives what we do. And part of what we do is focused around our research and development department. Research and development is where we actually came from, and we commercialized simulation so that instead of it being restricted 21 years ago to being something in a laboratory that a professor was able to engage with, we made it something that everybody, all engineers and so on, could engage with, and so that industry could move forward. As we look at it now, we still got a research and development department, and there's a number of projects that are European funded that are driving how we're interacting with the building life cycle. As I say, traditionally in the design stage, but now moving into the operation stage and other stages of the building cycle as well. We are currently in 140 countries. We're used by many engineering firms around the world who've used our software to go and analyze their buildings and inform their design decisions. You go and you generate your 3D model, and then you can, off that one platform, go and do a whole range of different types of analysis. And so that's something that was unique for us over the years, because you could go into that one platform, and whether you wanted to do your energy calculations, whether you wanted to go and look at Part L specifically, whether you wanted to go and look at daylighting or shading analysis, you could do it all off the one platform and the one model. So this meant productivity gains followed. Now what we're doing is we are seeing a situation that's meaning that we are moving out, not only meaning that we're moving out from the design stage to being out into the operational stage of the building. Now we do, as I say, we are working towards supporting all of the different stages of the building life cycle, and commissioning will be an area where maybe we would use our consulting services, because we offer not only software but consulting services, because we're obviously experts in this field too. So a particular area to look at here is driving building efficiency using operational data and 3D modeling. So this is where we're kind of pushing out into with our research programs, and we've got a number of research projects that's fueling that at the moment. So it is a work in progress, and I know, as we've heard from some of the presentations, it's an industry challenge when it comes to data and gathering that. But we have a situation where we have this performance gap, where you've got the design building, which has been designed, and you have your energy predictions, and then you've got the building in use, and you've got this situation where the building is just not operating anywhere near what it was predicted to, and that's for a myriad of reasons, not just design and construction, but also how the building is being used by the occupants. So it's about how do we approach that, how do we deal with that, and IES once again is trying to bring the technology that can address that issue, and that's what we're part of what we're doing. There are different structures that are pushing this forward, whether it's BREEAM or LEED as regulatory frameworks, or whether it's BIJRE's soft landings frameworks, and also the ESOS system in the UK, if you're familiar with it, Energy Savings Opportunity Scheme, which we also have a piece of software and support that in the UK. All these things are pushing us and recognizing recognizing that there is this performance gap that needs to be dealt with. So as I say, IES and how we sit into this is we obviously deal with these models, theoretical models, that when we combine them with data, if we can get that, it becomes a very powerful tool that can be used as we go and look at these buildings going forward. When we look at models, there's 4 different types of models really, if we kind of simplify it, and that alone can be quite confusing to designers and industry. So you've got your design model, which is the one that the architect and the engineer will work on and will be an actual design, taking in all the design activities in the space and all those good things close to what you're expecting the building to actually operate like. But there's going to be a lot of averages and assumptions within that as well. Then you've got a compliance model, which is something that might be used for Part L type analysis to satisfy regulations. And within that model, it's a little bit different because you're more restricted. You have to have an apples for apples kind of situation so that it's fair, and so they restrict down activity types, they restrict down they pin down certain things so that you're all on the same playing field. So it's a different type of model, and the reference model would come in there where it's kind of a benchmarked model that you compare your model against. So design model, a bit more flexible if we put it like that, whereas the compliance and reference model is a little more restricted for the sake of what it needs to do. And then there's the operational model, which is where we're looking towards now, where we've got this model that is well informed with building data that we can then calibrate and then look at different retrofitting solutions then. So as we look at this operational model and building data, so the operational model is an example, I suppose, of what a 3D model would look like, the traditional kind of 3D model, and then you've got this image of the data. And really for us at the moment, the data still is, I suppose, a big hurdle for us to get over. We've got to overcome it. In our experience, we've got a number of case studies and we've got a number of projects that we've been working on. And as we've gone through it, we found that, there is the technology there. There are the BMS systems and so on that have the capability to do what we need them to do, but unfortunately at the moment they're maybe just not operating in that way. So we are finding that even though maybe the data is being logged, it's maybe not being stored for long enough that it can inform a model over a course of a year perhaps. So Ergon is the first, I suppose, of the tools that have come out of this research and development that you can, I suppose, purchase. And I'll talk a little bit about what Ergon is, and then you've got CI Squared, which currently is more of a consultancy service at this point in time. So when you look at Ergon, what that is you first of all collect the data from wherever you can get it, data loggers, automated meter devices, BMS systems and so on. Then if you can get the information, you put it in to the Ergon system. Ergon, what it is, it's a cloud-based tool. It's online. You push the data into it, and it'll take a number of formats, and CSV format, I think, is the favored one. And you push the data into this tool, and you can check that data to see where there's holes in it, how complete it is, and it creates what's called free-form profiles. Now, when we think of a model that's at design stage, there's an awful lot of assumptions, and so you've got a lot of averaging and some flat lines and so on, whereas like this image down on the bottom right, actually, where you've got something that looks probably more like a design profile that's kind of averaged and flat, versus something that's actually an operational line, which is kind of a little bit more up and down in the way that it is. So what we do is we've got those free form profiles now, which you can take from Ergon. So you put your data in, you can analyze your data on Ergon, you can have a look at that and you can see it. You can go in, then create these free form profiles, and then those free form profiles are very powerful powerful because they can control a theoretical model like what we do, our dynamic simulation model. So we can plug those freeform profiles back into our model, and we can start to analyze those and look at those in Vista Pro, which is our results analysis tool. So I suppose one of the big benefits of this type of modeling process is that it becomes a holistic one, in that you can pull the data from different sources, you plug it into the model, and it makes up the entire story, and you can visualize it, you can see it, and you can start to compare between, if you've got the design model readily available, okay, great, you can compare that directly against your operational model, but you may compare it against something like a lead model or something of that nature, where you are wanting to see how you're comparing against that, or where the differences lie. We do have consultancy services as part of what we do. The company has an expertise in this area, so consultancy is always something we offer. We always have to stay at the cutting edge, and so there's a range of consultant services that we offer and we support our clients with here in Ireland and internationally as well. And one of those is CI Squared, and this is one of our latest consultancy services, and this is in line. Ergon makes up part of this, it's part of the technology. Because we've got the research and development section to what we do, there are other technologies that we can use in-house that aren't readily available commercially, but it means that we can go in and we can come alongside the different parties to take control of that building data with this technology, uncover hidden inefficiencies, so maybe things that aren't as easy to drill down and get to in maybe some other approaches by going to the controllers and whatnot. Versus using this model, you can uncover some hidden inefficiencies, and we've managed to do that with a few projects to date. You can reduce operational costs in so doing, and the whole process, CI Squared is more of a process at the moment rather than a software product, if you like. How it works is you collect the data, so our consultancy team will come alongside and help put an infrastructure in place to collect that data in a robust way. Then you investigate. So at that point, we help analyze that data, look at it, and see what it's telling us. We compare that to, if we have a design model, as we say, we can compare it to that. If we've got some reference model that's appropriate, we can compare it to that, and we can start to drill down into how the actual systems are operating. And then appropriately we can try and identify some quick wins. Where can we start to get some very quick payback, and we can make the appropriate investment. So we can do this, I suppose, in a way that we don't have to go and make the investment and then find out how it's interacting with our building. We of course can do this all in theory first and look at the model, a calibrated model, as I say, that's as close to reality as we can get. And once we've got that calibrated model, we can then go and retrofit it and see what kind of technologies are going to best fit this model going forward. One of the case studies that we have is the John Lewis York in the UK. John Lewis set some pretty stringent targets for themselves. So they said they'd reduce any of their new stores by 30% in terms of their energy efficiency. So what happened was they went and got Lateral Technologies, and they tasked them with designing one of their lowest energy stores. And so Lateral Technologies came to ourselves, obviously, because we're experts in this particular area and tend to get involved in some of the more complex modelling type situations. And so we used different modules that we have, because the software can go and model plant very effectively. You can go in and we can look at boilers and chillers in considerable detail and all sorts of bits of plant, and we can look at how efficient they're working and how to optimize those. So we went in, we did that, we got some of the building data that they did have for other stores, similar stores, and we then went and looked at putting that into our Ergon solution, taking any data they had, comparing it, and seeing where we can make some savings. So So it was a pretty hard task, but they managed to get the savings down to between 35 and 40%. And I'm just going to grab this one here because it has some of the figures on it that I don't know off by heart. But some of the things that they were pointed towards and the measures taken included installation of a 450 kilowatt chiller requiring 25% less energy than those in other stores, photovoltaics, roof panels to generate 4% of the store's electrical energy from a renewable source, the building air permeability of less than 3, and full LED lighting requiring 40% less energy than other artificial lighting methods. So they're just some of the measures that they looked at and saw as being the quick wins for this particular project that would bring them between 35 and 40% reduction in carbon compared to similar stores. So it's actually carbon is what they were trying to reduce. So that was that one. And then we also, and this is just a slide just showing how some of the mapping took place at a high level, just mapping the actual software inputs, so air temperature, room CO2, heating set point, lighting gains, and so on, and also how we map that then to the different data pots, if you like, that we could get. And it was very important for us. If we look at another example, there's the Glasgow City Council proof of concept. They asked us once again to come alongside them, as obviously there again we have expertise in this area, and we looked at a number of buildings. We looked at some schools, some museums, some offices for them, and what we did was we were looking at some of the data, and what we found is obviously there was some monthly data available, and that's really what the top right hand side represents, that kind of fuzzy picture there showing the monthly data. Very hard to really get very much information from that. Whereas when we were able to drill down a little further, we were able to get some more data, and we were able to get a lot more of the points throughout the year that we needed to see. And so we were able to go and see a much clearer picture of what was going on for a number of the buildings. And they did manage to identify that there would be some group cost savings, and managed to show that the energy investment strategy was one that was worth looking at. So I suppose as I finish, IES is a company that is progressive, where we have our research department, and we have a number of areas that we're developing and pushing out into, and this is just one of them. So over the next few years, keep an eye out for some of the technologies that will be coming out in this area, in particular in the operation areas of the building life cycle. Thanks for your time, and I think if there's any questions. I don't know how I'm doing on time, but
That's great, Gary. Thank you very much. Have we any questions for Gary? You mentioned about this idea of interacting with buildings, and it's certainly trying to what's the word, fill in that gap of targeted energy rating with an actual in use. Gary, you mentioned we've got manuals like soft landings, ESOS that are driving more kind of energy efficient ways of working within buildings, and this Ergon project, this freeform portfolio. But I was wondering how easy is that to use by clients, or is that maybe more for the M&E engineers, or is that where your consultancy comes in to try and translate all that data for clients to use?
Yeah, Ergon is really quite a simple tool to use, but it is about having the data to put in the first place. It would traditionally be used by engineers to go in, because they'll need to probably analyse the data and know what they're looking at. But in terms of usability, it is a cloud-based program. You simply put in the inputs, you're able to get a nice graphical interface. I didn't have any slides for that there, unfortunately, I'm sorry, but a nice graphical interface, and you can go and analyse straight away, what is this data saying to me, and then you convert it into the profiles, bring it into your model, and it brings you to a new phase where you can see it more holistically in the context of a larger model. And we can talk further. Myself and my colleague are here over at a desk over on the left hand side, so if anyone has particular interest in Ergon or any of those items I've talked about, I'm more than happy to discuss it and to take it forward.